This is a YouTube preview of a section of a course called ClojureScript for React Developers. This video is part 2 in a series of 3 preview videos. Sanitize the input. Our objectives are: we will trim any whitespace from the beginning and end of the text input string, making use of a function in the Clojure.string library. We will not allow the user to enter an empty string as the title of a to-do item. As our app currently stands, the user can add whitespace to the beginning and end of the input text for the title of a to-do item. Go to the browser. Input some text with spaces at the beginning and end. You can see in the console that the title of this to-do item has leading and trailing whitespace. We want to avoid this from happening. In addition, the user can currently add an empty string as the title of a to-do item. You can see in the console that a to-do item with an empty string as a title has been added. Our objective is to sanitize the input. First, we will trim off the leading and trailing whitespace. In order to do this, we will make use of Clojure's string library. Jump into the to-do input component's save binding. We will create a local binding named trimmed text inside this function. We will thread the value of the input text to the core stir function to make sure it is indeed a string and not, for instance, a number. And then thread it to the string library's trim function to remove any white space from the beginning and end of the text. Also, we will modify the next line. We will check to make sure that the trim text is not empty before calling add_to_do. You can verify for yourself in the browser that the input is sanitized before the to-do state is updated. Initialize app with sample data. Our objectives are: instead of hard-coding the sample data inside our app state, we'll add it via our add_to_do utility function. Doing this will simplify our app state. Currently, we have hard-coded some initial to-dos in state to display when loading our app. It would be better to start with an empty to-do state map and then call our own utility function API in order to add some sample data. Select and delete the definition of initial to-dos first. Now we will also delete the definition of initial to-dos sorted. Next, we will update our to-do state definition to initialize the ratum with a sorted map. And we will start the counter used for providing to-do item IDs at 0. Next, demarcate an area for initializing our app with sample data. When the app launches, we will add 3 to-dos via our add_to_do function. We will refresh our browser at this point to see our to-dos watcher print changes to the state in the console. Good, We have successfully updated our app to use a cleaner initial state and also a process for adding sample data. Delete to-do item. Our objectives are: we will create a function to delete to-do items. We will add a delete button to the to-do item view. And we will show the task list and footer control views only when there are some to-do items. The next feature we want to add for our users is deleting a to-do item. First, we will add a utility function to delete a to-do item from our to-do state. Define a delete to-do function that takes the ID of the to-do item to delete as a parameter. We will swap out the to-dos map with a new map which has dissociated the ID key. Jump to the to-do item component. The title field of the passed-in to-do item prop has been destructured. Let's also destructure the ID field. Add a button element after the label. Give it the CSS class name destroy. Add the onClick prop to the button. Pass it a function that calls the delete to-do utility with the ID. Let's test it in the browser. Hover your cursor over the wash dishes item. You can see the delete button appear at the right side of the item. Click it to delete the item. Good. Now we have a functioning delete button which appears when the user hovers the mouse cursor over the to-do item. To improve the UI when all of the to-do items have been deleted, hide the task list and footer controls. The idiomatic way in Clojure to only show something when there are some items available is to call seek on the sequence and wrap the result in a when call. If your to-dos list is empty, calling seek on it will return nil, and then calling when on the nil result will also return nil, and the component wrapped in when will not display. The only two values in Clojure which are logically false are the Boolean false itself and the value nil. Using nil as having a meaning equivalent to false in Clojure is called nil punning, and occurs frequently in idiomatic Clojure code. Let's test it in the browser. Hover over the Buy Groceries item and then click the Delete button. Now hover over the Do Laundry item and then delete it. We have no more to-do items left. You can see that the task list and footer controls are no longer visible. Good. We have successfully implemented the user-facing feature of deleting to-do items. Toggle to-do item. Our objectives are: we will create a function that will toggle the done value of a to-do item. We will change the CSS class of a done item so that it looks visually different in the UI. We will add a styled checkbox input for toggling the done value of an item. The next user-facing feature for us to implement is the ability to mark to-do items as completed. In fact, it would be best to enable the user to toggle each to-do item between completed or not completed. Let's first add a utility function that will update our to-do state when a to-do item has its done field toggled. Define a toggle done function that takes the ID of a to-do item as its parameter. It will swap the to-do state map with a copy whose done field of the to-do item with the input ID has its Boolean value reversed. The not function reverses the Boolean value, which in effect acts like a Boolean value toggle. Now jump into the to-do item component. Destructure the done field from the passed-in to-do item props. Add a class attribute to the list item element. When the done field is true, the CSS class should be completed. A space after the string completed was added to allow for the possible concatenation of other classes, which we'll get to soon. Add an input element before the label, which will serve as the user-facing checkbox input for toggling the to-do item. Add the CSS class attribute of toggle and type of checkbox. Control the input element with the checked attribute, setting it to the done value. Finally, add the onChange attribute, passing it a function which calls the ToggleDone utility with the ID. Let's test it in the browser. Click on the toggle checkbox on the left side of the wash dishes item. You can see that the checkbox is checked and the title of the to-do item is a faint grey colour and struck through as well. In the console, you can see that the done value of wash dishes is true. Toggle the checkbox on the same to-do item. It has toggled back to a done value of false. Good, we now have a styled checkbox input which shows when a to-do item is done or not and allows the user to toggle it. Pass props to to-do input component. Our objective is we will refactor our code so that we can pass additional functionality such as the CSS class and an onSave function to the to-do input view as props. It is time for us to do some code refactoring. Look at the input element of the to-do input component. It has hard-coded class and placeholder text. It would be more flexible and therefore more reusable if it received these values via props. In addition, what should the to-do input component do when it saves its input? At the moment, it adds a to-do item, but we should also allow for it to edit an existing to-do item. Jump to the call to to-do input in the task entry component. Add a class prop and give it the value new to do. Add a placeholder prop and give it the string what needs to be done. Add an onSave prop and pass it the addToDo function. Jump into the to-do input component to add the passed-in props as its parameter. Destructure the onSave prop. Inside the save binding, update the addToDo behavior to be onSave. Now jump to the inner rendering Clojure, which also needs to reference the props that were passed in to the component. Destructure the props to get the class and placeholder values. Replace the hard-coded CSS class value with the class prop value. And replace the hard-coded placeholder string with the prop value named placeholder. Good! We have successfully refactored our code, making the to-do input component more flexible and reusable. Edit to-do item. Our objectives are: since we will be making to-do items editable, we will keep track of when we are editing an item with a ratum local to the to-do item view component. We will update the class of a to-do item when it is in editing mode. Users will be able to double-click on a to-do item to start editing it. When editing, a to-do item will become an inline input field, which is a nice UI feature. Finally, we will write a save to-do utility function to update the to-do state. The user should be able to edit a to-do item rather than having to delete it and make a new one. Implementing this editing functionality for the user will require several changes to our code. Let's start by going to the to-do item component. Add a binding called editing. Bind it to a ratum whose value is initially false. Since we have bound a ratum within the reagent component, we will need to render the hiccup forms in a Clojure, explicitly passing through the props. In other words, the component needs to be a form2 reagent component. Since we no longer refer to the destructured ID, title, and done props in the outer component definition, we can remove them. We will refer to the props that are passed into the component using the underscore prefix to show that while we are aware of them, we are ignoring them. This is purely optional, and we just do it for additional clarity. Next, if the user is editing the input, concatenate the class string editing to the CSS class attribute. When the user double-clicks on a label in a to-do item, we will reset the editing atom value to true. Next up, when the value of editing is true, then we shall render a to-do input component. It will give the CSS class prop the value edit, which shows the input field within the double-clicked to-do item. Add a title prop with the to-do item's title. Also, an onSave prop which is passed a function that takes some text as an input and calls a function called SaveToDo with the ID and that text. We will define the SaveToDo function very shortly. The last prop will be called onStop, which resets the editing atom value to false. We need to define the SaveToDo utility for saving to-do items that have been edited by the user. Define a SaveToDo function and put the ID and title of the to-do item to edit as parameters. Swap the to-do state map with a new copy whose to-do item with the passed-in ID has its title field associated with the passed-in title text. Add the title prop to the destructured props in the to-do input component. And also destructure the onStop prop. Now, we will need the initial value of the input text ratum to be the value of the title prop, in case the to-do item is being edited. Next, we will need to add a function call to the stop binding, so we will wrap the bound expression in do. If the input is being edited, then call the value of the onStop prop, which will in turn reset the editing atom value to false. Finally, we'll update the footer info to tell the user how to edit a to-do item. Make it clear to the user that a to-do item should be double-clicked to edit it. Let's test it in the browser. Double-click on the Do Laundry item. We will need to click on it again to focus it. Edit it by adding the text Today. Hit Enter. Great! We have successfully implemented the feature that enables the user to edit to-do items. Focus on input. Our objectives are: we will show you how to add React lifecycle events to a Reagent component using the WithMeta function. We will show you an example of a Reagent Form 3 component, which is the main way of adding lifecycle events to a Reagent component. We will show you how to use a ref function in a Reagent component to access its actual DOM element. Finally, we will make good use of the autofocus prop. You may have noticed that double-clicking a to-do item makes it editable, but another click is necessary to bring focus to it so that you can type. Also, you may have noticed that the to-do's input field does not focus when the app first loads. Either of these does not make for a great user experience. We will show you 3 different ways to improve this UX. The first will highlight the use of the WithMeta function, which you can use to add React lifecycle methods to a Reagent component. Define a view component with the name of TodoEdit. We will put it under the To-Do input component. The WithMeta function takes a Reagent component and adds a map with metadata. We will take the To-Do input component and add a map with the key component did mount. This adds the component did mount lifecycle method, which React calls when the component is first created. This is a good place to access the actual DOM node created by the component and focus it. The function passed to the component did mount key has access to this, the current component. Call the DOM node function from the reagent.dom library on this component and then call focus on it using interop with JavaScript. The SomeThreadFirst macro is an elegant way of ensuring that the DOM node exists before calling focus. The DOM node function in the reagent.dom library corresponds to the findDOMNode method in React's JavaScript API. Now, in our To-Do item component, we will call this metadata enhanced To-Do edit component in place of the To-Do input component. This is the approach shown in Reagent's official documentation, on the page with live examples. However, there are two problems with this approach. First, it does not focus the to-dos input field when the app is first loaded. This is because to-do edit is only called when we are editing. Second, using the DOM_node function, like React's corresponding findDOM_node method, is an anti-pattern. FindDOM_node is deprecated. We shouldn't be using it. Instead, we should be using ref functions to access the DOM node. Let's go back to where we were before adding the DOM node function via withMeta and try using ref functions instead. Now we are back to where we were earlier. We will first go to the to-do input component and make it into a so-called Form3 reagent component. Reagent Form3 components call the core library's createClass function. It takes a map which must contain the key reagent render. It takes a render function, such as the function we have already written. Now let's define a binding named bangRef. Bind it to a Clojure atom, not a reagent atom, with the initial value of nil. We use a Clojure atom instead of a reagent atom because we do not need to cause a re-render when it is dereferenced. Now go to the map argument of createClass. Add a key of component_didMount. Pass it a function which takes this component as an argument, which we can ignore here. Dereference the bangRef atom and call the focus method on its value via interop with JavaScript. Use the SomeThreadFirst macro to guard against nil. And now add a ref attribute to the input element rendered. Pass it a function that resets the bangRef atom value to the HTML input element accessed. It is good practice to add a display name key to the map in createClass. This will help you when debugging warnings and errors. Good. We now have a better solution for our UX issues. Nevertheless, there is a much simpler solution than those we have shown you. Let's revert back to where we were when we had the UX problems. We can make use of the autofocus prop on the input element. Simply set it to true. This is the simplest and best solution for our UX issues. Toggle all complete. Our objectives are: we will add a checkbox input so that the user can toggle all the to-do items complete. We will define a complete all toggle utility function that will update our to-do state. We will explain in detail how to update several values in a map using the map function. Start off at the top of the rendered content of the task list component. Add an input element. Give it an ID attribute of toggle all and a type attribute of checkbox. As a sibling of the input element, add a label. Give it the for attribute of toggle all to associate it with the input element. Add the label text mark all as complete. You can see the checkbox with label mark all as complete in the browser. We will add a CSS class that will push the checkbox visually into the input field and give it the appearance of a downward pointing arrowhead icon. With this CSS styling, the input label's text is no longer visible. Let's click on this checkbox input control. Let's talk about how the toggle all checkbox control should work. If not all to-dos are done, then clicking toggle all should mark them all as done. However, if all to-dos are already done, then clicking toggle all should mark them all as not done. Let's create a binding to determine if all to-dos are done or not. We will call this predicate allComplete ? It is simply calculated using Clojure's every ? function, passing it the done keyword function as the first predicate argument and the items collection as the second argument. This is yet another example of how concise, yet expressive, Clojure's core library functions can be. Now we'll move on to controlling the input checkbox. We will add the checked prop and pass it the local predicate function we have just defined. Now add the onChange prop. Pass it the yet to be defined complete all toggle function wrapped in a lambda. And pass the negation of the Boolean value of allComplete ? to it as its argument. Now let's define the complete all toggle utility function. It will take a Boolean value as its parameter. Before we move on, it may be helpful to explain how to change all to-do items done value to the Boolean value b. Here, we start out with the dereferenced to-dos atom, which is a map. In the center of the slide, we demonstrate performing a map operation on each key value pair of the dereferenced to-dos, invoking a function g on each pair. The map operation puts the results into a sequence, which you see at the bottom of the slide. The map operation starts with the first key value pair in the map. It puts the key value pair from the map into a so-called map entry, which is a vector whose index 0 is the key and whose index 1 is the value. Our goal is to change the false value of the done field within the to-do item map, which sits at index 1 of that vector. We know that in order to update part of a nested data structure like this, we need to use the associateIn function, specifying the data structure as the first argument and the path to the value to be updated as its second argument, and the target value as the third argument. We have defined g as a function where we associateIn to the vector input, taking the path to index 1, which represents the to-do item map, and then moving to the to-do item map's value of the done key, setting it to true. This results in the updated vector, which the map operation puts into its output sequence. The map operation then moves to the second key value pair of the dereferenced to-dos. The map operation internally converts the key value pair into a vector, which is then transformed and added to the output sequence. Then the map operation moves on to the final key value pair, and it goes through the same steps. until it has added the last transformed vector to the output sequence, which it returns. Let's now define the transformation function of the map operation as a local binding and call it g, as we did in the slides. We will bind it to the association function. Now we will update the to-dos atom by passing it a function which operates on the to-dos state value, which happens to be a sorted map. We can generically name M. We will thread this map last to a map operation using the function g we just defined locally. We want to transform the result of the map operation, which is a sequence of vectors, into the same structure as M, which in our case is a sorted map. We do that as follows. Now let's test it out in the browser. We will reload the browser to clear the console logs. We will click on the downward pointing arrowhead icon. All the to-do items are now marked as complete. Let's click on it again. All the to-do items are now marked as active. Good, we have successfully added the toggle all complete functionality. Clear completed. Our objectives are: we will render a button that will remove all the completed to-do items. We will define a clear completed function that will update the to-do state. Finally, we will refactor our code to remove duplicated functionality in our utility functions. Let's add the clear completed control to our footer. First, we will create a local binding. We will call the values of the deref to-dos atom items. Next, create a binding called doneCount, which will be the number of to-do items that are marked done. We will count the to-do items that pass through a filter over the items using the done keyword as a function. Now we will indent the body of the view component to take care of the parentheses. Let's remove the div placeholder. We will conditionally render a clear completed button when the done count is positive. Add a button element with the CSS class of clear completed. Add an onClick prop, passing it a yet-to-be-defined function called clearCompleted. And give the button the label clearCompleted. Next, we will define the clearCompleted utility function. It will take no parameters. Create a local binding. To clear all the completed to-do items, we will need to run a map function over all of them. This map function will itself take a function to transform each individual to-do item, which we will call g, as in the previous video. It will use the getIn function, which takes a single map entry from to-dos. The map function pulls it in as a vector, as explained in the previous video. So we will move to the first index of the vector, which is a to-do item map, and then get the value of the done keyword. Now we will swap the to-dos atom using a function over the value of the to-dos map m. Thread the map last. Delete the items which are done by calling the remove function, making use of the locally bound transformation function g. Finally, we will need to transform the output sequence into a sorted map, as we did in the previous video. We now have a functioning clearCompleted utility function. Let's test it in the browser. Reload the browser page. Mark the wash dishes item as done. We can see that the Clear Completed button has appeared. Click it to clear the to-dos that are done. We can see that the wash dishes item has been removed. We have successfully implemented the Clear Completed functionality. But we can improve our code before we move on to adding further features. We can see that the Complete All Toggle and Clear Completed utility functions have similar functions to swap out the to-dos map. They both take the current to-dos map, perform a map or remove operation using the gbinding function on each item, and finally put the resulting sequence of items into an empty map. We can improve on this unnecessary duplication with some code refactoring. We will follow Reagent's official documentation and create a function called mmap. It takes a map m and a function that operates on a collection, such as the map or remove function. We will call this function f, and a function g, which operates on the element in the collection. We have used this variable name in our bindings. Now we will write the body of the function. Thread the map as the last argument to the collection function f using the element transform function g, putting the resulting sequence into an empty version of the map m. Now we have this utility function, we can update Complete All Toggle. We are swapping the to-dos atom using our new mmap function. The first argument to mmap is the current value of the to-dos atom, which is implicitly supplied by the swap bang operation. The second argument to mmap is the map function. And the third and final argument is g. We have successfully refactored the Complete All Toggle utility function. Now we will refactor the Clear Completed function in the same way. Pass the mmap function, then the remove function corresponding to f in mmap. Finally, pass the local binding g. We have successfully refactored the Clear Completed utility function. Add other footer controls. Our objectives are: we will create a label showing the number of items left to do. We will create a filter that will control whether we show all to-do items or just the active or done to-do items. Finally, we will create clickable links for these filters. We want to add a label in the footer showing the user how many items they have left to do. First, add a binding to show the number of to-do items that are not done, which we will name ActiveCount. This is calculated as the total number of items minus the done count. Add a span element with the CSS class of TodoCount. Within it, add a strong element around the active count, so that it appears bold in our UI. Follow that up with a space and then the text items left. Let's test it in the browser. We can see the text 3 items left. Click the Done toggle on Wash Dishes. Now we can see that 2 items are left. Click the Done toggle on Do Laundry. Now we can see that the label shows 1 items left. Let's fix the grammar there so that it shows 1 item left. Show item if only 1 item is active, otherwise show items. We can now see the correct grammar on the page. We want to add additional controls to the footer. The user may want to see just the list of active to-dos, or just the to-dos that are done, in addition to seeing all the to-dos. We will add a filter to our list. Call the filter Showing. It will be a ratum with an initial value of the keyword all. Showing can take one of 3 possible keyword values to filter the to-do items. The 3 values are all, active, and done. Since we have an atom bound in our view component, we will need to return a closure. Indent the rendered body to fix the parentheses. We will need to pass the showing atom into both task list and footer controls as an argument, since it will be used in both as a filter. Now we need to add showing as a parameter in the task list and footer control component definitions. Start with the task list component. Make a local binding for a function to filter on. We will use the case macro on the value of the showing atom. In the case it has the keyword value done, then filter using the keyword function done. In the case it has the keyword value active, then filter using the function complement to the keyword done. Finally, in the case it has the keyword value all, just apply the identity function, which returns every input passed in without changing it. Now create a binding called visible items, which will be the filtered list of items. It applies the filter function to the to-do items. Instead of running the sequence comprehension on all items, we need to change it to the filtered visible items. Now move to the footer controls component, passing in the showing atom as a parameter. Now we will control the value of the showing filter using clickable anchor links. We will wrap the anchor links in an unordered list. Give it the CSS class called filters. Create a list item element and within it an anchor element with an empty string to start with. Duplicate this twice. The first link should have the text all. The second link should have the text active. And the third link should have the text completed. The links now appear in the footer of our app. We want each link to update the showing atom when clicked. To achieve this, add props to each link. We will call a function named props4. It will take the keyword we want the showing atom to be updated to. The first link will take the keyword all. The second link will take the keyword active. The third link will take the keyword done. Now we will create a binding for the props4 function. Bind it to a function that takes the keyword value of the showing filter. Return a map with a class key and a value of selected when the value of the showing atom is the same as the keyword passed in to the function. Add a key of onClick, which will be the onClick prop. As the value for onClick, reset the showing atom to the keyword passed in. And finally, add a key of href with a value of #string, so that the links cause the cursor to change to a pointer when hovered over. Now let's test it out in the browser. First, click on the active link. Now click on Completed. Finally, click on All. We have verified that it all works as intended. We have successfully implemented the showing filter. Our To-Do app now has the same features as the TodoMVC example in the official Reagent documentation.